Hi, I am Vinod Gupta. I am Senior Director of Engineering at RapidFort. Today I am going to show you how with RapidFort platform you can take a Redis image, instrument the Redis image with some RapidFort software so that we can generate profiles and we can create a much smaller, secure, hardened Redis image. So first step is I'm just going to pull the Redis latest image. So we are pulling the Redis image from the Docker Hub registry. You will see that officially Redis image was released by the Redis core team 20 hours ago. It's 117 megabytes in size. Now I'm going to take this image and run it through the RapidFort platform. On your system, when you install the RapidFort tools, we have RF login, which is used to authenticate to the RapidFort platform. We have RF scan, which can be used to scan any Docker containers on your system. We have RF stub, which uses our existing Docker container, adds RapidFort platform into your container so that we can generate profiles. And we have RF harden, which is used to create a hardened image. So let's begin. So I'm going to simply do is RF stub. I'm going to pick the Redis image and I'm going to send it to the RapidFort platform. At this time, what's happening is we are picking up the Redis image, which is on your system. We are sending it to the RapidFort platform. We open this container image. We look at all the files, all the system calls, and all the Debian packages and different language packages on your container image. And we generate an SBOM. We also have a statistical model. This statistical model can predict how many vulnerabilities RapidFort platform can remove. We can also predict how much attack surface can be removed from this particular image. So here, let me take you to the UI to show you how this predictions look like. So I'm going to the Redis image. This is the Redis image which is in stub ready. We just generated. Here you'll see our platform predicts that we can reduce about 79% attack surface. We can also remove about 75% of vulnerabilities, and we'll be able to reduce about 79% of packages. Below you can see a breakdown of all the vulnerabilities present in the system. There are 5 critical vulnerabilities in this Docker container, 35 high, 27 medium and 13 low. Let's look at the different vulnerabilities. We have multiple sources for the different CVs. If you click on the CV, you can see from various sources this CV was created. You can find the package in which this particular CV exists. And if there is a fix available, we also show the fix version. Other thing we have generated is something called rapid risk score. Rapid risk score is an estimation of how soon a proof of concept or exploit will be available for a particular vulnerability. Typically, what happens in cybersecurity world is once a CV is reported, there are researchers who release a proof of concept followed by an exploit. Exploit means that somebody can now go attack your infrastructure and get some remote code to work on it. So you want to prioritize fixing these vulnerabilities based on the rapid risk score. Let's come back to our CLI. I'm going to take this RF stubbed image, which is about 145 MB in size. What we have done here is we have added the RapidFort software into the original image so we can generate the profiling information. Once we are done with the profiling, we will be removing all the RapidFort software from this particular image so that hardened image doesn't have anything running from RapidFort. So let's begin the process. I'm simply going to first run the RapidFort stubbed image. So you run the RapidFort stubbed image as you'll run any other image. Only thing we ask is to add a sys ptrace capability so that we can get permissions to do the profiling of this container. Here you'll see that Redis container is working like a regular Redis container. Now I'm going to look at all the Docker containers which are running. I just exercise docker ps command. This is the process ID of the container which is running. Now I'm going to take this process ID and exit into the container with a Redis CLI. So I'm going to run some manual command like ping. I will also see demo. I can exercise this demo command. And that's pretty much it. I have exercised the basic functionality I want to include in my container. Now I'm going to stop the container. Other functionality I want you to see in the system is I'm going to run the same command again. If you go into a UI, into the log section, you'll be able to see the dynamic logs flowing from our system. So you'll see how many times Redis CLI is executed at runtime. Coming back to the Docker container, we have already a stub ready now because we executed the RF stub. I also want to include one more application in my final image. So we have the option to create an ignore file or profile file where you can list the files or folders in the git ignore format and provide it during the hardening process. This will ensure that these packages or files, even though they are not exercised, belongs in the final hardened image. So I'm going to simply do rf harden redis. I'm going to the latest rf stub tag and I'm going to pass this profile. If you believe that you don't want to whitelist anything, you can ignore these commands. At this point, what we are doing is our platform knows that what all packages and files were touched and exercised during your stub image run. We take that profile and then we look at the files present in the Docker container, and based on that, we generate a hardened image. The hardened image is 40 megabytes in size and it has much less vulnerabilities, which will be pretty visible in the UI. So I'm going to just refresh my UI and I'm going to go to the vulnerability section. So here you'll see we got 65% reduction in the attack surface. So instead of 116 megabyte, now my hardened image is 40 megabytes. You'll see that the number of vulnerabilities have gone down from 80 to 18. You will also see that the number of packages has reduced by 91%. Below you can see a complete breakdown of how many vulnerabilities we removed by each category. So in the final container, we just have 3 vulnerabilities which are critical instead of 5. We just have 5 hardened vulnerabilities versus 35 on the original container. You can also go to the file section to see a complete list of files. So original container had 4,855 files. We used about 23 files during our stub run. Now we have an intelligent system which can detect the dependencies of these files so that your container can run without any problems, and that's why we included about 29 files. You can also get a flat view of all the files and you can download all these reports. Now let's look at the packages. Original Debian image had about 96 packages. We just needed 7 to run this image, and there were about 2 Golang packages. We also profile the system calls. So original system had 334 system calls available, out of which only 86 were used. You can easily download a seccomp profile from our system and use that to create alerts for security in case a non-whitelisted system call is called. Now let's go back to the Redis CLI to see whether this newly created hardened container even still works or not. So Redis hardened container is 40 megabytes in size. So I'm going to do is I'll use the same command which we ran, but I'll remove the extra capability we needed to profile the container. And I'm going to use the tag which was just created, which is 40 MB in size. So here I'm running the RF hardened image. It ran like the original Docker container. But let's see even if this works or not. So I'm going to do a docker ps. This gives me the process ID of the container for the latest RF hardened image. I'm going to first run my basic test to see if the functionality even works. I'll do ping, I'll set a key, demo works, get key. But then maybe there are other things which my simple test case is not showing. So how about we run a Redis benchmark, which is a test suite developed by the Redis team, and see if this will work. I'm going to set up 1000 iterations for the purpose of this demo. And I'm going to use the same process which is already running. Oh, there is a small typo. Let me fix the typo. So here you'll see that we are able to run the Redis benchmark on this RF hardened image and it works perfectly. That's all from this demo. So here you saw that we picked up original Redis image, which was 117 MB image. We created a SBOM, which showed all the different vulnerabilities in the system. Then we created an instrumented image, which had a 30 megabyte extra software from RapidFort, which helps us in profiling. And then after running our use cases and ignoring the files we wanted, we were able to generate a 40 MB image. I want to emphasize one more thing. The amount of data we add stays constant around 30 MB. So even if you have a 1 gigabyte or 2 gigabyte image, we only add 30 megabytes to those containers. And then finally in the hardened container, none of the RapidFort software exists. It's just the files which were used to be able to run your container. I also want to point out that these sizes are based on the test cases we execute. If you want to add additional functionality in your container or preserve other behavior, these sizes might vary. For more information, please visit at rapidfort.com, or you can sign up for our free tier and exercise this functionality yourself. Thank you.